Hi folks, welcome back to Math with Captain Rod. This is intended to be video 3, section 2.2 of your notes. There's a bunch of graphs there, and the directions are to indicate where the intervals, or identify the intervals over which the function is increasing, decreasing, or constant. So the first graph, this picture looks something like this. Now, you'll notice that as we go from left to right, the x values, we're moving to the right, and the graph is getting higher and higher and higher and higher. So this graph is increasing the entire time. When they say what interval is it increasing on, it's increasing as long as x is going from -4 to 3. So in interval notation, we would write it like, like this. -4 to 3. Looks like it's increasing right there, so I'm going to go ahead and include those values. Hard bracket here means including -4. Hard bracket here means including 3. So the reason I'm including these values is, imagine if the function kept going. Right at that spot, it is, I would say, still increasing. So because it's still increasing at that value, that's why we use what I call here a hard bracket. So here's the notation for it. This is a value of x between -4 and 3. The function is increasing. All right, next example, and I'm just going to sketch it real quick. The next example on the lower left looks something like this. Boom. Boom. All right. This point, according to the example, I'm looking at this, that looks like -4,2 to me. -4,2. This point right here, that's an important point. That's -2, 0. This point right here is, that looks like 4, 5 to me. 4, 5. All right, so where is it increasing? Actually, it says to identify where it's increasing, decreasing, or constant. So let's do decreasing first. So as we move, as x goes from -4 to -2, this function is dropping. See how these heights are getting less and less and less. So it is decreasing on the interval from -4 to -2. All right. Okay, what's actually happening at -2 here? It's going from increasing to decreasing. We're going to want to not include that -2 there. So I'm just going to take a moment and kind of rethink those brackets here, if you pardon me. Okay, so having rethought that, I'm going to go back and chat about this one again. This function's increasing as we go left to right, but the function's not defined on the left-hand side of this. So what it's actually doing right at -4, I don't think that we should include that equality there. I'm going to go back and change that to a soft bracket, both here and here. Soft bracket, remember, means not including. So this now is saying x between -4 and 3, but not including -4, not including -3. Apologize for that. This point here is what kind of reminded me of that. So at this point right here, this is kind of a change between decreasing and increasing. What it's actually doing, like at that instant, is kind of an undefined thing here. We're not going to include the -2 here. And as I look to the left, we don't really, this function's not defined to the left-hand side of this. We don't want to include -4 in that. So I'm going to go ahead and put, again, I'm going to make that a soft bracket. So this thing is decreasing from -4 to -2, not including the -4, not including the -2. Okay, now from x equals -2 to 4, the function's getting bigger. So it is increasing on the interval -2 to 4. Again, not including the -2, not including the 4. All right. Next example. Let's see. Next example I see on the page. Let's see. We've got a bracket, or I'm sorry, a graph that kind of looks like this. Now, there's kind of some interpretation you have to realize. Even though it kind of looks in the picture that this thing's going straight down, I'm pretty sure that what they mean by this function, this is not an asymptote, it kind of goes infinitely far down and this way. This function, based on what I'm seeing here, is defined everywhere, to the left and the right. So the domain of this function is all real numbers, and the range of this function is also all real numbers, because this function's getting infinitely big this way, and infinitely big this way in a negative sense. So as we go from left to right, You got to imagine being way down here. As we go from left to right, when x goes to the right, the function is going up, 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 up. So as I look at this thing is increasing forever. So increasing for all values of x. I'll just put all x. That one's done. All right, next one I want to talk about is upper left. Whoops. Oh, there we go, clear. All right, so I'm just going to do again a quick sketch. Upper left. You'll notice this quadratic looking function is looking like this. The vertex here is at the point 2, 4. All right. So now you got to consider what's happening here. Again, this thing's quadratic. That means it's defined on all real numbers. The range of this function, well, the highest value here is 4, and all the y values have to be less than that. So the range is y has to be greater than or equal to 4. You could also do this in interval notation. You could say that, you know, y is on the interval 4 to minus infinity. That would be another way to kind of express that. All right. So, you know, you got to think about what's happening as we go left to right. As x is going left to right, the function is getting bigger and bigger and bigger. So this thing is increasing on the interval from minus infinity to 2. Because that's the x coordinate here where things change, not including the negative 2. That's why the soft bracket. Now, from here on out, you'll notice that the function value, that's this distance, this starts getting smaller and smaller and smaller. Right? This function is decreasing. Now, even though the distance is getting bigger, this is still decreasing. Think about like your bank account. You know, negative 100 versus negative 200 versus negative 300. Right? You're getting worse off. Right? That's still basically decreasing. So this thing is decreasing on the interval from x equals 2 to plus infinity. And again, not including the 2. All right, so that's that example. Get rid of that one. Next one. All right, I see a graph. It looks like this, this, this. Now you notice in this region, the function values, that's these distances, they are not changing. Again, look at your paper. Mine might look like it's changing slightly, but the actual ones on the graph are not. This is an important point here. This is the point 0,2 according to the graph. Now that's a point, not an interval. This is the point, looking at the graph, I would say that's the point 3, negative 4. All right, so in this region, the function is constant. So it is constant from minus infinity to 0. While I'm at it, it's also constant in this region. So it's constant from 3 to plus infinity. So I'm going to put in and from 3 to plus infinity. All right, there's the region where it's constant. It is decreasing on this interval. So I'll put decreasing on the interval from x equals 0 to 3. Not including 0, not including 3, and hence the round brackets. All right. And increasing, there is no location where this thing is increasing. I don't see any increasing anywhere to be found here. So, next example. All right. I'm just going to do a quick sketch here. I see a graph that looks like this with this inverted V-looking type function. It looks to me like this point right here is the point 2, 3. Yep. All right. Now, again, presumably this function, as x goes this way to minus infinity, y is going this way to also negative infinity. Over here, this function goes on forever. So as x goes to plus infinity, y is going to minus infinity. So as we go from left to right, this function is increasing all the way to x equals 2. So we are increasing on the interval from minus infinity to 2, not including the 2, hence the soft bracket. And then we are decreasing from x equals 2 to the right. So that's going to be the interval from 2 to plus infinity. And there's no point here where this thing is constant. So I think that's enough on this video. It's hitting 10 minutes here. I think we'll just stop that there and start another one. Have a great day.